So we will look at this question 2 sum, and the question is given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. And here we have the nums list, that's 2, 7, 11, and 15, and then the target is 9. So when we are 2 and 7, we would get 9, so we would return the index, that's 0 and 1. And here we have another example where we have 3, 2, and 4, and the target is 6. And when we are 2 and 4, we would get 1 and 2. So, and here the order doesn't matter, we can return 1 or 2 or 2 or 1, and either of those would be fine. And here we have another example where we have 3 and 3, and when we add both of these numbers, we would get 6. And here what we have to do is we have to return a separate index. So we cannot do, even though 3 plus 3 by itself would give us 6, we cannot do 0 and 0, or 1 or 1 or 1, or 1 and 1. So we have to do 0 and 1. So it has to be a different element. And so the first way we will do it is we will do the brute force way. And in the brute force way, let's suppose that we have num1 as 11, and then num2 would be all of these elements one at a time. And if these don't add up to 10, then we will move to the next element, which would be, so num1 would become 22 now. And then num2 will be all of these elements one at a time. And if we still don't find it, we will keep on moving forward. And then num1 will be 1, num2 would be 77, num2 would be 88, and 9. And when we add 1 and 9, we would get 10. And that's the same as the target. So we would return the index of 1 and 9. So we will do for I in range length and nums. And here our num1 would be nums I. And then we will do for j in range I plus 1. Actually, it doesn't matter. You can have the space in between or not. It doesn't matter. It doesn't do anything. And then we will do length and nums1, length and nums. And here we will do num2 is equal to nums and j. The reason over here we do I plus 1 is because if num1 is this 3, and if we don't do I plus 1, then j would also be, or num2 would also be 3. And that would be wrong, because that we would get 0 and 0. So it's important here that we do I plus 1, so that way num1 would be 3, and the num2 would be this 3 right here, which is at index 1. And here we will do if num1 plus num2 is equal to target, then we can return I and j. And again, here we can do I and j or j and I, and both of those would be fine. And I wouldn't be surprised if it times out, but if it doesn't, so it's fine. But it takes a lot longer. It takes 3820 milliseconds. And now we will talk about the time complexity and the space complexity. So for space complexity, it takes O1 space, because we're not really storing any elements. We just get the element, and then we just compare that to the target and see if that is if those two numbers add up to the target or not, and then we just move on to the next number. So in terms of space complexity, is fine. It's great. It's taking O1. But the problem is with the time complexity, because in terms of time complexity, it takes O1 squared. And the reason it's bad is because, and this is what O1 squared looks like, that as the number of elements increase, it just takes a lot longer for the algorithm to compute what those two numbers would be. So in the beginning, it would be fine when we have fewer numbers, and hypothetically speaking 5, 10, 15, 20 numbers maybe, it would be fine. But as the number of elements keep on increasing, it will just take a lot longer. So if we have, and again, hypothetically speaking, if we have 200 elements, it will not take twice as long compared to if we had 100 elements. It will take a lot longer. So that's why O(n) squared is really bad. Um, so now what we will do is we will try to optimize this and see like how we can do better than this. And in order for us to do better than this, what we will do is we will store each number in a dictionary, and then we will calculate the difference and see if the difference already exists in the dictionary, and then return the indexes for those. So for example, let's take this example right here, example 2, where we have 3. So what we will do is we will create a dictionary, and then we will see if the difference of 3 already exists in the dictionary or not. So 6 minus 3 would be 3, and we will see if the difference already exists. And since this is the first element, it doesn't exist in the dictionary, so we will store 3 in the dictionary with the index of 0, and then we will move to the next element, and we will do 2. We would have 2, and we will do 6 minus 2, that's 4, and we will check if 4 already exists in the dictionary or not, and 4 doesn't already exist in the dictionary. So what we will do is we will store 2 in the dictionary with the index of 1, and then in the next iteration we will have 4, and 6 minus 4 is 2. So we will check if 2 already exists in the dictionary, and 2 already does exist in the dictionary. So then what we will do is we will return the indexes of 4 and 2, the number that was already stored in the dictionary. So here we will initialize and declare the dictionary, and then we will do for index and num in enumerate and nums. And what enumerate would do is it would allow us to have access to index and the number value at the same time. Or I guess we could also do for I in range and length, and then we can get the number value that way. But since this is already there, we can just use enumerate to get both the index and the number value. And here we will do stored num, and here we will do target minus number, and then we will check if the stored number is already in the dictionary or not. And if the stored number is already in the dictionary, then we will get index 2, that would be dictionary and stored number, and then we would just return and actually this should be index 2, and then we would just return index 2 and index. So this index 2 would be this index, and then this index is this one right here. And let's suppose that the stored number was not already in the dictionary, then we will store the original number, in this case 3, into the dictionary, and then the next iteration 2 into the dictionary. So here we will do dictionary and num is equal to index, and let's run this. And as you can see that this took a lot. Last time it took 56 milliseconds. So now we will talk about the reason is because we are only doing one pass, that we, since we calculated the difference that way, we are only traversing through the list as many times as many elements there are. So in terms of space complexity, we are looking at O(n) because we have to store all of the elements into the dictionary. As I mentioned earlier, that when we are comparing these two numbers, if the number doesn't already exist in the dictionary, if the difference of the target and the value doesn't exist in the dictionary, then we would store that number into the dictionary. So that's how we have on space complexity. And in terms of time complexity, we're also looking at on because we're always moving forward, and we don't have a nested for loop or anything.